So, Hari Om. In the operating system course, we are currently in module 2, and we had already covered this process concept, process scheduling, and operations on processes. And all these points we discussed earlier. Under process concept, we discussed what do you mean by a process, what are the different states of a process, or you call it as process life cycle also, right? And how do you store the process information in a process control block. Then we also talked about process scheduling, and in process scheduling we talked about what do you mean by scheduling queues and what are the different schedulers available, like long term, short term schedulers. Long term scheduler is also known as job scheduler, and the short term scheduler is also known as CPU scheduler. Then we also talked about the operations on processes yesterday, where we talked about what is process creation and what is process termination, because these are the two very important operations that are done on processes by the operating system. So today we are going to talk about the cooperating processes. Yesterday we had seen when the processes are created by the operating system, we can have two types of processes. One is called as independent process, the other one is called as cooperating process. So the independent process will not affect other processes. In the same way, the independent process will not be affected by another process. Both the cases, right? So it is not going to affect anything, and this will also be not affected. Whereas if you have cooperating processes, and these cooperating process will affect another process, in the same way any other process will also be affecting the cooperating process. A two-way, right? In both the ways it will be affected, right? Now the question is, why should we have this cooperating process? Why don't we have only independent process, and why cooperating process is available in an operating system? So the advantages are, if you want to have information sharing by more than one process, then you need to have cooperating process. Or if you want to increase the execution speed, then you can go for cooperating process. Or if you want to have modularity, as we had already discussed what is modularization, so breaking the larger problem or larger task into smaller task is what you call as modularity. So whenever you break it into subtasks, all these subtasks need to be interact with each other, right? You have a larger problem, it is decomposed into smaller problems, and these smaller problems will have their own solution, and obviously all these smaller problems are part of one particular task. If this is the case, all the smaller solutions or processes need to communicate with each other. So you need a cooperating process there. And the last one, convenience. Obviously, if you want to enhance the programming environment of your operating system, you can go for cooperating process. Okay. Now, what are the reasons for providing an environment that allows process cooperation, right? So we are going to little deeper into these four advantages. First one is information sharing. Concurrent access to such information that are shared by more than one process. That is what you call as information sharing. So you have one information, there is one information, and this information will be shared by more than one process. And please see that it will be done as a concurrent access. That means you have process 1 and process 2. Both process 1 and process 2 are going to access the same information. But for example, you may be having a database. You have two processes. Process 1 is reading some data from the database, and process 2 will be writing some data into the database. So that is what you call as information sharing. Same information, which is your database, that will be accessed by more than one processes, which you call as information sharing. Second one, as I told you, computation speed up. You are going to break the task into smaller tasks and each of which will be executing in parallel. അപ്പോൾ ഒരു പ്രോഗ്രാം കണ്ടിന്യൂസ് ആയിട്ട് എക്സിക്യൂട്ട് ചെയ്യുന്നതിന് പകരം വാട്ട് യു ആർ ഗോയിങ് ടു ഡു, യു ബ്രേക്ക് ദ പ്രോബ്ലം ഇൻ ടു സ്മോളർ പ്രോബ്ലം. എന്നിട്ട് ആ സ്മോളർ പ്രോബ്ലത്തിന് ഓരോരോ പ്രോബ്ലമും സെപ്പറേറ്റ് ആയിട്ട് എക്സിക്യൂട്ട് ചെയ്യാൻ വന്നു, ബട്ട് ദേ ആർ ഓൾ എക്സിക്യൂട്ടഡ് പാരലലി. അപ്പോൾ ഓബ്വിയസ്ലി ഇറ്റ് ഇൻക്രീസസ് ദ സ്പീഡ് ഓഫ് എക്സിക്യൂഷൻ. The third one, modularity. I told you, dividing the systems into separate processes or subtasks or threads, that is what you call as modularity. Then convenience, many tasks will be done at the same time. So if you are going to break the task into smaller tasks, many tasks will be done at the same time or at the parallelly in the operating system. So these are the reasons for providing an environment which allows the cooperating process. If I want these advantages, I need to have cooperating processes in an operating system. If you want to have cooperating processes, then the cooperating processes require a mechanism called as interprocess communication. So I recollected, if you want to have cooperating processes, then these are the different advantages, and these advantages are the reasons to be specified for the cooperating processes. And if you want to have cooperating processes in an operating system, you need to have a mechanism called as interprocess communication. So let us see what is interprocess communication mechanism. Interprocess communication is also known as IPC mechanism, which will allow processes to exchange data and information. So you have process 1 and process 2, and these two processes are running parallelly or they are running concurrently. By the time they need to exchange some data and information, which you call as interprocess communication. Now to achieve this interprocess communication, there are two models available in the operating system. First one is called as shared memory. The second one is called as message passing, right? So to have interprocess communication mechanism, two models are available in the operating system. What are the two models? Shared memory and message passing. So let us see what is shared memory and message passing. This is the diagrammatic representation of shared memory and message passing. So if you observe, this is what you call as shared memory model. This is shared memory model, whereas this is message passing model. And if you observe here, I have process A and I have process B. In between I have a memory also, which is shared by both process A and process B. So this is a region of memory where we can store some information which can be accessed and manipulated by both process A and process B. Please make a note of it. This is a region of memory in which you are going to store the information and data, and both this information and data that you are going to store in this region can be accessed and manipulated by process A as well as by process B. This is what you call as shared memory. For example, let us assume that you have a file. So what I do, I will load this file into this shared memory region. Both process A and process B can read that file from this particular region. This is what you call as shared memory, right? Or process A can write something into the file which is stored in the shared memory, and process B at the same time can read the data from the file which is stored in the shared memory. You call it as shared memory model. Whereas the second model is what you call as message passing model. Here what I do, you are going to have a message queue. So this is the message queue, right? And in the message queue you can have all the messages which are sent by one process or the other process. So you have process B sending the messages, the same way process A is also sending the messages, and process A will be accessing the message which are sent by process B, and in the same way process B also will be accessing the messages which are sent by process A. So this queue is accessed by both process A and process B. So whatever information they want to exchange, that will be stored in this particular queue. So process A will be accessing the message from this queue. The same way process B will also be accessing the message from this particular queue. This is what you call as message passing model. So these are the two models available for the inter-process communication. So let us see what is shared memory model. Here a region of memory will be shared by the cooperating processes, and the processes can exchange information by reading and writing the data to the shared region. So that is what I showed you in the previous slide. And the second model is the message passing model. Here what we are going to do, the communication will take place by means of messages exchanged between the cooperating process. That is what we had seen in the previous slide. And whenever you are going to have only a smaller amount of data being exchanged, you can go for the message passing model. But if you have large amount of information being exchanged between the process, we go for the shared memory model, right? So for smaller amount of data, we can use message passing, but if you have larger information to be exchanged, then we can go for shared memory model, right? So memory will be shared by the cooperating process. So that is what is shown here. Memory will be shared by the cooperating process. These are the two cooperating processes which are coming under inter-process communication. Process A and process B wants to share some information. So what you do, ഏത് information ആണ് share ചെയ്യേണ്ടത്, that information will be put in this particular region. So both of them will get access to this particular region. Whereas in the message passing model, the communication will take place by means of exchanging the messages. How do you exchange the message? You put it in a message queue, and both process A and process B will be accessing the data. Okay, and as I told you, whenever we have smaller amount of data being exchanged, we can make use of the message passing model. Whenever we have shared memory model, we use it, whenever we have large amount of data to be exchanged, we use the shared memory model, right? So that's it about your inter-process communication. So in the inter-process communication, we had seen what do you mean by cooperating processes, what are the reasons that allow the cooperating processes we had seen. And if you want to have cooperating processes, you need to have inter-process communication mechanism. And what do you mean by inter-process communication mechanism we had seen. To achieve this inter-process communication, we can have two different models in the operating system. One is called as shared memory, the other one is called as message passing. So shared memory is nothing but a region will be a region of memory will be shared by both the processes. Not both, I should not say only two processes. You can have more than two processes also. So all the n number of processes will be accessing and manipulating the data that is stored in a common memory region. Whereas in the message passing model, what we do, we will have a message queue, and all the cooperating processes will be storing their messages in the message queue, which can be accessed by other processes also. So that is what you call as message passing model, right? So with that we are completing the process concepts, like the basics of what do you mean by a process and what do you mean by the process creation, process termination, inter-process communication. All those concepts we have covered in the first part of the second module. Now the second part of the second module is going to deal with CPU scheduling, the most interesting part. So we'll be discussing it in our upcoming session.